Okay, Walkers, everyone at journal page 58. Using graphs and properties to solve equations with exponents. Steps to solve exponential equations graphically. Step 1. Graph the left side of the equation. Step 2. Graph the right side of the equation. Step 3. Find the point of intersection. Step 4. The x value of the point is the solution. Alright, steps to solve exponential equations algebraically. Step 1. Isolate the b to the x value. Step 2. Take the log base b of both sides. Step 3. X equals is the solution. All right, let's take a look at the first example. All right, the equation 2 equals 1.01 to the x power miles of population that has doubled. What is the rate of increase? What does x represent? The rate of increase is 1%. X is a number of units of time. All right, let's take a look at the next example. All right, solve the given equation. Okay, so we have 14 times 2 to the x equals 112. First step is we're going to divide both sides by 14. 14 divided by 14 is 1. So then you get 2 to the x equals, let's go ahead and use our calculator. So 112 divided by 14 is 8. Okay, so you have 2 to the x equals 8. All right, so now we do log base 2 of both sides. Oh, put too many 2s there. Log base 2 of 8. All right. So to understand what's happening here, let me just use the calculator real quick. If I do control log base 2 of 2 to the, let's just say 5 power, you can see that the log base 2 of 2 basically cancel each other and you're left with a 5. So applying that here, these cancel, you're left with x equals log base 2 of 8, which put in the calculator. So control, let's delete that, control log base 2 of 8 is 3. Okay. Now, let's look at this graphically. So I'm going to add a tab here, go to desmos.com, go to graphing calculator. Now, we're going to graph the left side. So we're going to graph y equals 14 parentheses 2 to the x. Okay. Enter. And then we're going to graph 112. Oh, we need to graph y equals 112. Okay, now I'm going to zoom out. It's going to take a while because we're trying to get to 112. And we click at the point of intersection, and we can see our x value is 3, which is our solution. Okay? All right, so let's go back to our next example. Bring in a little bit. All right, so here we have 8 to the x power divided by 4 equals 16. Okay, now what we need to do is multiply both sides by 4. So then you have 4 times 8 to the x power divided by 4 equals 4 times 16. Well, 4 divided by 4 is 1, so you're left with 8 to the x power equals 4 times 16. We can use our calculator real quick. Is 64. Okay, now we're going to take log base 8 of both sides. that cancels. You're left with x equals log base 8 of 64, which we'll put in the calculator to get our value. So we're going to do control log base 8 of 64, and you can see x equals 2. Okay. Now let's go to Desmos and let's find the solution that way. So we're going to graph y equals 8 to the x divided by 4 and y equals 16. And I'm going to press the home key to go back and then zoom out. Click right there and you can see our solution is 2. All right, let's take a look at the next example. All right. So the first thing we're going to do is multiply both sides by 5. So then that becomes 5 divided by 5 times 6 divided by 7 to the x power equals 5 times 72 divided by 490. Okay, well 5 divided by 5 is 1. So then we have 6 divided by 7 to the x power equals, we can use our calculator for that. So 5 times, let's see, control divide, 72 divided by 490 is 36 divided by 49. Okay, so now we're going to take log base 6 divided by 7 of both sides. Okay, well, that cancels. You're left with x equals log base 6 divided by 7 of 36 divided by 49, which we'll put that in our calculator. So control log, control divide, 6 divided by 7, and then control divide 36 divided by 49, and you see we get 2. So x equals 2. Okay, so again, we're going to use Desmos. Let's press the home key before we forget, and then we're going to graph y equals 1 divided by 5, parentheses 6 divided by 7 to the x power, and then y equals 72 divided by 490, and we're looking for the point of intersection, and you can see that our x value is 2. All right, let's take a look at the next example. All right, so here it looks like we need to divide 5 by both sides. Well, 5 divided by 5 is 1, so you're left with 8 divided by 5 to the x power equals, let's go ahead and put this in our calculator. So we're going to do control divide, 64 divided by 5 divided by 5 is 64 divided by 25. So it equals 64 divided by 25. Now we're going to take the log of 8 divided by 5 of both sides. This cancels. You're left with x equals log of 8 divided by 5 of 64 divided by 25. And let's go ahead and put that in our calculator. So control log, control divide, 8 divided by 5, control divide of 64 divided by 25 is 2. Okay, so let's go ahead and use Desmos. So we have y equals 5 times 8 divided by 5 to the x, and y equals 64 divided by 5. And now we're going to zoom out, and we can see here that our solution is 2. All right, let's take a look at the next example. All right, example 7. Okay, so it looks like the first step is we're going to divide both sides by 7. Well, 7 divided by 7 is 1. You have 13 to the x power equals, let's go ahead and divide this right here. So 1183 divided by 7 is 169. So now we're going to take log base 13 of both sides.
Pardon the interruption. Ms. Lujan, please call Ms. Lee at 7018. Once again, Ms. Lujan, please call Ms. Lee at 7018. Thank you.
Okay, so that cancels. You're left with x equals, and then we're going to put this in our calculator. So I'm going to press Control log base 13 of 1696, and we can see that, oh, whoa, wait a second. I wrote something wrong. Let me go back here. I apologize. Somehow I accidentally wrote a 6 there, which is weird. It should be 169. So let's go back and put that in the calculator. So Control log of 13 of 169 is 2. Okay, so x equals 2. Okay. So now let's take a look at it graphically. So we have y equals 7 times 13 to the x, and y equals 1183. Now, it's going to take a while to zoom out because that number is quite big. Oh. And we need to kind of zoom in on that aspect. And so that's where you have to be careful. You don't want that. You want the actual point on the line because they're very close. This is the y-intercept, and that's the point of intersection. And you can see that that is 2. So be careful when the number gets that big. You might have to zoom out to find the intersection and then zoom in to find here. Because if you see here, if you don't zoom in too close, you'll get that point, which is wrong. We don't want that. We want the point of intersection. All right. So let's take a look at the next question. All right. First step is we're going to divide both sides by 2. Okay. 2 divided by 2 is 1. So then you have 6 divided by 13 to the x equals, and let's go ahead and put this in the calculator. So we're going to do control divide, and that's 72 divided by 169 divided by 2, which is 36 divided by 169. Okay, so then we're going to take log base 6 divided by 13 of both sides. Okay, that cancels. You're left with x equals log base 6 of 13 of 36 divided by 169. And let's go ahead and put that in our calculator. Okay, so control log base control divide 6 divided by 13 of control divide 36 divided by 169. And so x equals 2. All right, so let's go ahead and use Desmos to check to make sure that's correct. So y equals 2 parentheses 6 divided by 13 raised to the x, and then y equals 72 divided by 169. And then you want to press the home key. Point of intersection is 2, so our work is correct. Now let's take a look at the next example. All right, example 13. There is a drought and the oak tree population is decreasing at a rate of 9% per year. If the population continues to decrease at the same rate, how long will it take for the population to be a third of what it is? If necessary, round your answer to the nearest tenth. Okay, so the population equals the initial population times 1 minus 9% would be 0.09 for the t. Okay? But what we want to know when the population is 1/3. So we want to know when the initial population is divided by 3. Which would then be equal to the initial population times 1 minus 0.09 t. Now, the reason why I put the divided by 3 at the end here is because we need to divide both sides by the initial population. Now, anything divided by itself is 1. So this becomes 1, this becomes 1. So you have 1/3 equals 1 times 1 minus 0.09 to the t. Now, we can use the graphing method to solve this. So that's what we're going to do. We're going to go to Desmos. We're going to graph y equals 1 divided by 3. And we're going to graph y equals 1 parentheses 1 minus 0.09. Now, we can't use t. We have to use x. Okay. And then we're going to zoom out a little bit. And right there is our point of intersection. So t equals, they said round to the nearest tenth, so that would be 11.6. Okay, so the population will reach a third of its original value in approximately 11.6 years. All right, let's go and finish up that example. All right, let's take a look at example 14. An animal reserve has 44,000 elk. The population is increasing at a rate of 19% per year. How long will it take for the population to reach 88,000? If necessary, round your answer to the nearest tenth. Okay, so our population will equal to the initial population times 1 plus, it's increasing, so that's plus 0.19 to the t. Now, we want to know when the population is 88,000. Our initial population is 44,000 times 1 plus 0.19 t. Now, these numbers are quite big, and you can honestly graph this as is to find the solution. So let's do that. We don't want the calculator, we want Desmos. So I'm going to graph y equals 88,000 and y equals 44,000, parentheses 1 plus 0.19 to the x power. Okay, so we're going to have to zoom out to get to 88,000, so that's quite a ways to go. All right, we're there. We can see the intersection. Now we need to zoom in and make sure that we have the point of intersection. Okay, and it looks like we have 3.9 years, which would round to 4. So t would equal 4. Okay, now okay, so the population reached 88,000 in approximately 4 years. All right, let's take a look at the next example. All right, Lisa has a credit card that charges 5% interest on a monthly balance. She buys a $320 bike and plans to pay for it by making monthly payments of $160. How many months will it take her to pay it off? Assume the first payment she makes is charged no interest because she paid it before the first bill. So month 1, we need to take 320 minus 160. Okay, so let's go ahead and do that. So 320 minus 160 is $160. Okay, so she has $160 left to pay after month 1. So month 2, we need to take 160, multiply it by 1.05, because that's your interest portion. Okay, and then minus 160 from that. Okay, so let's use our calculator. So that's 160 times 1.05 minus 160 is $8. Okay, so in month 2 she owes $8. So month 3, we need to take 8 times 1.05 and subtract it from 8 times 1.05, which would be 0. Okay, so it takes her 3 months to pay it off. Okay, go ahead and finish up the last example, and start working on your assignment. Have a wonderful Wildcat day.